Hello my dear students. Once again I would like to welcome you for the another session of non-conventional machining processes. Today we are going to learn about the electric discharge machining, ultrasonic machining and abrasive jet machining process. So let us begin with the first one, that is electric discharge machining process. Simply we can call it as a EDM. The electric discharge machining is the process of metal removal from the work surface due to the erosion of the metal caused by electric spark discharge between the two electrode tools, that is cathode and the work which is connected to the anode. These are nothing but the positive and negative supply, electrical supplies given to one the tool and another one for the work material, as we give in the electric welding, arc welding processes. This process is also known as a spark erosion or electron erosion or spark machining process. So the electric discharge machining process is as shown in figure. In this figure we can able to see the DC pulse generator or a power unit which is having a positive and negative terminals. The positive and negative, in between the positive and negative terminal we have the voltmeter, and here is the ammeter provided to this one, and the positive supply is given to the work material, as we can call it as a anode, and the negative supply is given to the tool which is having the shape of the cut which we wanted to provide on the work surface, and the work material is immersed in the dielectric fluid, and this dielectric fluid is to be circulated with the help of a pump, and the filter is provided between the circulation process to avoid any unwanted material such as the particles eroded from the work material is to be stopped in the filter itself. So let us see how this particular electric discharge machining process will continue. It consists of an electric power supply, the dielectric medium, the tool and workpiece, and a servo control or a motor. The workpiece is connected to the positive terminal and the tool is connected to the negative terminal of the DC power, that is direct current power supply. An air gap of 0.005 to 0.05 mm is maintained between the tool and the work interface. Okay. When the dielectric fluid, which is a non-conductor of electricity, the meaning of the dielectric means it is a non-conductor of electricity, is forced under the pressure through the gap. As you can see here, the dielectric fluid is forced with the pressure of the pump. Then what happens? When the DC power is supplied, the fluid in the gap gets ionized and produces a spark between the tool and workpiece. Okay, when the DC power is supplied to this particular tool and work interface, when this dielectric medium is in between this gap, it is ionized and catches the electrical sparks. When the DC power is supplied, the fluid in the gap gets ionized and produces a spark between the tool and workpiece, causing the local rise in the temperature of about 10,000 degrees Celsius, which melts the metal in a small area and of the workpiece and vaporizes the metal surface. The electric and magnetic fields on a heated metal causes a compressive force which removes the metal from the work surface. The dielectric fluid acts as a coolant carrier, and the eroded metal particles, which is filtered regularly and supplied back to the tank. A servo mechanism is used to feed the tool continuously to maintain a constant gap between the two electrodes. The accuracy of about 0.005 mm can be achieved by this process. As you can see here, this particular tool is going to feed into the work surface with the help of some servo electric motors. They are feeding regularly with a constant speed towards the work surface and maintaining the particular gap of 0.005 to 0.05 mm continuously to give the electric sparks between this tool and work interface to make the work material melt as well as vaporize. So this is how the electric discharge machining process will takes place. Now we discuss about the applications of EDM, that is electric discharge machining process. So EDM is used for drilling a micro holes in a nozzles and thread cutting operations, and it is also used for wire cutting operations, rotary form cutting operations, and helical profile milling operations, and it is used for curved hole drilling operations and engraving operation on harder materials, as well as cutting of operations and for shaping of alloy steel and tungsten carbide dies. And what are the advantages or the merits of using the electric discharge machining is that the first one, it can be used for any hard materials, as we can see in the previous non-traditional machining processes. It can also be used for harder materials, and any complicated shapes made on the tool can be reproduced with the help of engraving process, and high accuracy of about 0.005 mm can be achieved with the help of electric discharge machining process, and it provides the good surface finish. Machining time is less than the conventional machining process, and no mechanical stresses can develop in the process. However, the mechanical stress relieving operations can be avoided with the help of non-traditional machining processes, and higher tool life due to the proper lubrication and cooling. Hard and erosion resistant surfaces on the dies can be developed easily, and it can be applied to any electrical conductive materials. Whereas the disadvantages of the EDM are it uses excessive tool wear and a high power consumption, and sharp corners cannot be reproduced, high heat development causing the change in metallurgical properties of the material, as well as workpiece must be electrical conductor, otherwise it is impossible to, or it cannot be possible to do the electric discharge machining process. And surface cracking may takes place in some materials, and redressing of a tool is required for deep holes.